So we are going to start to talk about the x and y intercepts. And I've already kind of mentioned them in a couple of things we've done before. But the intercepts are just simply where a graph could be a line. That's going to be our main focus. But you'll talk about intercepts in any graph that you come across as we move through the semester. So the intercepts are just where the graph crosses whichever axis you're talking about. X-intercept, where a graph crosses the x-axis. Y-intercept, where a graph would be crossing on the y-axis. So let's take a look at a couple of examples here. And we're simply going to just identify where the x and the y intercepts are located. We'll just write them as ordered pairs. Okay, so let's take a look at the x, and if you notice on this example, there are two places where the x-axis gets crossed. So the x-intercepts here are at -2, 0, and 1, 0 when I write those as ordered pairs, which is typically how I will ask you to write intercepts, rather than just say x equals 2, -2, or x equals 1, because that really starts to look like the equation of a line. So I like intercepts to be written as ordered pairs. So the y-intercept on this one is at 0, -3. All right, so let's go down here, and again, let's continue. This time we'll have a line. So as you start to look at this graph, you'll see this time there's only one x-intercept, so only one place where the graph is crossing on the x-axis. Again, happens to be at -2, 0. And then again, if I was to look at a y-intercept, so where the graph would cross on the y-axis, this time it's at the ordered pair 0, 3. So what I want you to notice, this question 3, what is common to the x-intercepts? So when you look at the x-intercepts, I want you to observe that if it's right on the x-axis, that will mean that its y-coordinate will have to be 0. So when we are looking at the x-intercepts, the y-coordinates will always be 0, meaning we're looking at things of the ordered pairs ordered pairs that look like a number, comma, 0. So you're looking at ordered pairs of the form a number, comma, and the y-coordinate is 0. All right, so now suppose I said let's focus in on what do we notice is the same when we're looking at a y-intercept. So when I look at a y-intercept, I want to observe that it is the x-coordinate here that is always 0. So as I look at the y-intercept, it is the x-coordinate that is equal to 0. So that is, we're looking at ordered pairs of the form 0, comma, a number. So the x-coordinate was equal to 0. And that is actually how we will go about finding the equation of a line. Or I'm sorry, that is how we will go about finding the x and y intercepts given the equation of the line. So given an equation of the line, if I say to you, find the x-intercept, you're going to say, hey, I know what that means. That means the y-coordinate, I'm going to let the y-coordinate equal 0, and then I can just solve that for x. And so that is going to allow me to figure out what the x-coordinate is when the y-coordinate is equal to 0. And then if I say to you, find what the y-intercept is, you're going to say, I know what that means. That's where I let the x-coordinate equal 0. And then I can solve that for y. And so that's where I'll figure out what the y-intercept is given a particular equation. All right, so let's look at an example. Sometimes these are very quick, easy points, these intercepts to find because you're working with zeros. All right, so let's say we have the equation y equals x minus 1 over 2, and we're going to find each of these intercepts. So let's say I start here with looking for my x-intercept. So remember, the x-intercept is going to be where you're going to sub in 0 for the y-coordinates, and then you're going to figure out what the x-coordinate is. So 0 is what goes in for y, and then you're going to solve this equation for x. So an equation with a fraction, first thing we would do, let's clear that denominator. So let's multiply both sides by 2. Nice thing is, on the left-hand side, 0 times anything, 0 times 2 is still just 0. And then on the right-hand side, you have your x minus 1. So then we'll just go ahead and add that 1 to both sides. And so now we end up with 1 equaling x. So now to complete this ordered pair, again, this is now what the x-coordinate is, given that we started with the y-coordinate of 0. So that is our x-intercept as a ordered pair, 1, 0. All right, let's also find our y-intercept. So just think to yourself, you're always subbing in 0 for the other variable. So you're subbing in this time 0 for x, and you're going to solve for y. So 0 is what gets subbed in for the x variable. So you're going to have y equals 0 minus 1 over 2. Well, that's even quicker than the last one, because that's just y equals negative a half. It's already solved. So again, this is what your y-coordinate is when we started off letting the x-coordinate be 0. So this is your y-intercept. So make sure you have the two of those separate. Sometimes I'll see students call the x-intercept the y, or the y the x, or switch the zeros. A lot of little mistakes like that. So if zeros are so nice to work with, and they are, what we can do is we've been plotting points. That's how we've graphed lines so far, is just plotting a bunch of points. So let's just plot the intercepts if they're so nice. So the first kind of formalized, I guess I would say, technique to graph a line is just to find points, but in particular, find the x and y intercepts. And then we'll typically still find like a third point just to verify we haven't made a mistake in our arithmetic. But technically, all you need to graph a line is 2 points. So guess what? Technically, the intercepts are enough. But we're going to find a third point just to verify. All right, let's give this a go here. So we're going to find, again, x and y intercepts. Okay, let's start with our x-intercept. So x-intercept is where, again, we're going to sub in 0 for y and figure out what the x-coordinate is. So 0 goes in for y, so we're going to have negative 2 times 0 equals 6 minus 3x. So that means I have 0, and maybe you just kind of start like that. 0 equals 6 minus 3x. And now we just need to solve this for our x variable. So let's just add the x term to the left-hand side. And we're going to have 3x equals 6. And then our last step here, of course, dividing both sides by 3. We're going to get that the x is 2. All right, so as an ordered pair, remember this is our x-coordinate, and it started off when the y-coordinate was 0. So this is my x-intercept sitting over here at 2, 0. All right, let's now find the y-intercept. So the y-intercept is where we're going to sub in 0 for x and solve for y. So subbing in 0 for the x, so I'm going to have negative 2y equals 6 minus 3 times 0. And so that means that whole 3 times 0, that whole term is gone. So I have negative 2y equals 6. And solving here, just dividing both sides by negative 2, I now end up with my y equals negative 3. So again, let's keep in mind, this was my y coordinates when we started off letting 0 be our x coordinates. So my y-intercept here is 0, negative 3. Now there's a number of ways to find and verify a third point, and I'll kind of talk about a couple of them. One is just to pick anything you want for either the x or the y, quite honestly, and then sub it in for the other variable. So if you wanted to pick a third point, you can do absolutely whatever you want. Now, some of you are going to be a little bit better at just looking at the equation and kind of picking a number that's nice to work with. But when in doubt, something I see a lot of students do is they might just pick 1 for x. As long as that wasn't the x-intercept, because then you would just get that same point again. So that would work. It may not always be the nicest point, but I don't want you to panic if it's not the nicest point. Like in this case. So if I sub in 1 for x, I get 6 minus 3 times 1. So 6 minus 3 is 3. And so unfortunately, I do sometimes get fractions. But guess what? These lines go through an infinite set of points. They will go through fractions. Now, every once in a while, if you're graphing, on a homework assignment or something, you may not be able to on a computer. It may not allow you to use a point that goes through a fractional location. So you may have to try to get a different point. But in this case, this would be fine. We started off with 1 for x, and then we got back negative 1.5 for y. So we are over 1, and then we're down 1.5. So as I look at graphing this line, the other thing I can look at is just the fact, if I look at my two intercepts, first of all, everything appears to be lining up. As I go from the nice integer values of 0, negative 3, and then to 2, 0, it kind of looks like I have this idea going up 3 units and to the right 2. And I'm really just kind of leading you into these concepts we're going to talk about with slope. Or equivalently, I'm going down 3 and to the left 2. So if you can already get a feel for this idea of this pitch or slope, it's going to make the slope section really pretty straightforward here. All right, so there's my line. There's my line. All right, let's look at another example here. So suppose we have for number 2, negative x minus 2y equals 4. So let's go through this one a little bit more quickly. So our x-intercept, so remember, this is where we're going to sub in 0 for y and solve for x. So when I do that, that whole y term is going to be gone. So I'm just going to have negative x equals 4. And then, of course, just dividing by negative 1, x is going to be negative 4. Okay, so my x-intercept here is simply negative 4, 0. So there's my x-intercept. Okay, if I wanted to then, or since I am finding the intercepts, I'm using the intercepts method. The y-intercept will sub in 0 for x and solve for y. So that makes the whole x term go to 0, and I'm just left with negative 2y equals 4. And so then, of course, just dividing both sides by negative 2, we're going to end up with our y coordinate being negative 2. So x was 0, and now y is negative 2. So 0, negative 2. So I'm going to show you a kind of a little bit of a cheat, if you will, to find a third point. So sometimes what I do is I just extend my graph. I mean, what I did before is certainly valuable, if I can talk. It's valuable, and it certainly is valid. It can, sub in 1 for x and solve for y, and that would be fine. But the other thing I tend to do is I might kind of count out my slope like I was talking about before. Like if these 2 points are right, what am I doing? I'm going down 2 and to the right 4. So what happens if I go down 2 and to the right 1, 2, 3, 4 again? Or if I go down 2 and to the right 4, if I go up 2 and to the left 4 or something. I might take one of these points, like let's say this one for my third point there. So I might take that third point and say, okay, let's look at the point that looks to be sitting at 4, -4, and let's just check. Let's just sub it in and see if it works. So if I sub in 4 for x and -4 for y, I get -4 plus 8, and this looks great because the right-hand side of the equation is 4. So that's what I tend to do a lot of times when I'm trying to find a third point, is I might just extend my slope, kind of hoping and assuming that my first 2 points were correct, like in this case my intercept points, and then find that third point, but then I definitely check it and I make sure it works. And that's a check, like, okay, it seems like it's right, and I plug it in and it works. So that's what I might do for a third point, is just kind of pick one and then check it. All right. I think we will do maybe just 1 or 2 more here. Okay, so let's take a look at 3y equals 9 plus 2x. All right, so again, I'm having us stick with, for right now, these intercepts. So let's get even quicker on these. So I want you to realize that this can be a quick technique. Students don't often use it, but I think they're missing out an opportunity here. All right, so for an x-intercept, that's going to be where we sub in 0 for y. In fact, I'm not even going to write that much work. 0 for y is going to give me 9 plus 2x. And then let's finish solving this then for the x. So maybe in this case, I'll subtract the 2x over to the left-hand side. So -2x equals 9. And then we will divide both sides here by -2. And so I have 9 over -2, -9 halves, which in order to plot it would be -4.5. So this x-intercept, written as an ordered pair, was -9 halves, or -4.5, comma 0. So again, especially when we're doing things by hand, you won't always be able to avoid getting fractions for some of these ordered pairs. All right, let's take a look at a y-intercept. So for our y-intercept, that's where we sub in 0 for the x. So this one will be real quick, because that just gives me 3y equals 9, because that whole x term will be gone because I put in 0 for x. And so this one was super fast. That's just y equals 3. So as an ordered pair, what did I do? I subbed in 0 for x, and I got back 3 for y. So 0, 3. All right, and so again, that should technically be right. My whole third point idea doesn't work quite as well with this one, because I'm in a fractional location on that x-intercept. So that's where our first technique is probably valuable, is just to try to sub in some point. I'd also say that sometimes kind of a third approach is, some of you might be able to maybe just kind of look at some numbers and sub some things in and see what you get. It kind of depends on the student in that case here. But let's say I was to sub in, let's say I wanted it to come out even. You know, if I sub in 1 for x on the right-hand side, Then I have 11, and that's not going to be a multiple of 3. Maybe I sub in 2, that would be 4, and then 9 and 4, that's going to be 13. That's not going to be a multiple. But if I get to 3, 2 times 3 would be 6, and 6 plus 9 would be 15. So this is a way sometimes, and if you don't like thinking through like what would be a nice number, don't worry about it. Sometimes you're just going to get fractions, and that's okay. So maybe I just sub in x equals 3. And so if I do that, I get 3y equals 9 plus 2 times 3. So the reason I did that one is 9 plus 6 is 15, and now I'm just going to get kind of a nicer number to work with. But again, don't lose a lot of sleep over that if this doesn't seem very intuitive for you. So what did I end up with here? I ended up with the ordered pair 3, 5. So over 3 and up 5. The whole idea of the third point is really just to make sure, if you have 2 points, you really could have a mistake there. But usually if you get 3 points and they're falling into a line, chances are you're okay with your arithmetic. It's just a really good check to make sure that we haven't made a mistake there. Okay, one last one here. So number 4, y equals 7 halves x minus 7. All right, so on the x-intercept, so my x-intercept, remember, we're subbing in 0 for y. So this one, and what you'll notice is oftentimes one of them might be a little bit more work than the other. This one is going to take a couple steps anyway to solve it. So let's say I get my plain number on the left, I'll add my 7. And so I'm going to have 7 equals 7 halves x. And then remember to solve an equation here that has a fraction times a variable, and you're just down to having to get rid of that fraction. This is where you want to multiply by the reciprocal. So if you multiply by 2, and at the same time if you divide by 7, you're multiplying by the reciprocal of 2/7. So on the right hand side, of course, that becomes 14 over 14, so just x, 1x, which is x. And on the left hand side, actually this is pretty nice, those 7's reduce, and I just get 2. So this x-intercept actually isn't too bad. It's 2, 0. So I have an x-intercept of 2, 0. My y-intercept on this one's going to be a lot easier. And I want you to kind of notice something here. We're going to see this later when we focus on this type of a form, when it's solved for y. When that x term is gone, we just get that constant term. So when an equation is solved for y, the y-intercept is actually just going to be that constant term. And so some of you may even remember that if you've studied a little bit of lines before. So here's a second point. And again, if I was to think about this one, especially since I'm in nice integer locations, if I'm going up 7 over 2, let's do it again and say I go up 7 and over 2. And let's check that third point that I'm picking. So I'm picking that point right there for my third point. So my third point here is, what is that? It's over 4 and it's up 7. So I would check that, and that would give me y is 7 equals 7 halves times 4 minus 7. Well, if I think about multiplying those two fractions in that first term, they reduce. 2 goes into 2 once, it goes into 4 twice. Or think of it as 28 divided by 2. 28 divided by 2 would have been 14, or in this case, now it's just the 7 times the 2, which is 14. And then, of course, 14 minus 7 is 7. So that definitely is on the equation of my line. All right, so we'll just graph that line. Got a pretty steep one in this case. This is where I should be using my ruler, but just gonna finish that out freehand. All right, when we come back next time, we're gonna look at focusing in on those special cases of horizontal and vertical lines.